So good afternoon, everyone. Welcome to Kubeflow 101. My name is Abhijeet Rajwade. I am a cloud engineer at Google NYC. I have decade and a half years of experience working with enterprise customers. And one of the key issue of selecting a right technology is whether I will get locked into the same vendor or not. That is the main worry for all the stakeholders. And that's why I love Google Cloud and its support for open source technology. Today, we are going to learn about Kubeflow and how it can be run on GCP. So often when we talk about building a machine learning application, we are talking about developing a core model with libraries like TensorFlow, scikit-learn, XGBoost, and so on and so forth, and then deploying the model. But when you are building, deploying, and running a machine learning application in production, there are many other stages. A production machine learning application is often running continuously. It's running 24 by 7 by 365. Data is coming in on regular basis, either streaming in or as batches on periodic intervals. Models have to be constantly updated and improved upon and deployed. And of course, before you deploy any newly trained model, you have to make sure that the new models are safe for deployment. For the data that is streaming in, you have to do data pre-processing and data validation and make sure that there are no data quality issues. Then, after that, you do feature engineering followed by model training with hyperparameter tuning, followed by model validation, and so on and so forth. So what is needed is simple tooling to orchestrate and manage these multi-phase machine learning workflows and the ability to run them reliably and repeatedly. And that is the problem that Kubeflow Pipeline aims to solve. Now let's quickly look at these blocks in a sequence to understand the process of ML model building. You start with thinking that you're going to be building a model. The model, you start doing actual work, you realize, well, there is a lot of other stuff you have to do around before you even get your hands on TensorFlow or something to train your model. You start with data. You have to figure out where to get your data into your system, from data analysis, data transformation, validation, creating test sets, training sets, and then training a model, building a model, experiment a lot of it, and then you want to validate your model and figure out whether it actually does what you're looking for. And after that, you want to train at scale, roll out the model to production, then build an application around it. Then eventually you want to monitor and have logging as well. So what's the problem in this workflow? Well, setting up an ML stack or a pipeline is incredibly hard. Anybody who has done this, I think, would agree with me that you need to install a lot of tools, either on your desktop, workstation, wherever you're working. You get swamped into a lot of engineering, and that is where you need to install and get things connected, working together, figure out networking and other things. And doing this on production environment is even harder. You have to be careful. You're not messing things up that are already there. If you productionize your model in the wrong way, you might end up with making completely wrong predictions from what the data scientists intended when they actually trained the model. And setting up an ML stack that works across different clouds or different deployment is extremely hard. If you look at our experimentation stack, you are building a model, you are training locally, trying things out. You have a lot of stuff running on your laptop and enabling you, starting with hardware at the bottom with accelerators, operating system drivers, runtime, and then storage. And on top of this, you have your frameworks that you actually use to train and build your models. On top of the stack, you're going to be installing a bunch of microservices that enables you to compose and create your workflow all the way from reading the data, training, and then testing out your model and making predictions. Now we take it a step further. You have got to do this whole thing over again when you actually want to train your model at scale. We all would love to train the models with the volume of data that we have available. The more data sets, the more data points you are able to use, hopefully you get better accuracy in your model. And then finally, you actually want to deploy your model onto cloud, where the endpoints are accessible to users and they're making a difference in real world, the actual intention of your model. Kubeflow help us with orchestration and experimentation across these environments. Kubeflow's mission literally is to make it easy for everyone to develop, deploy, and manage portable distributed ML on Kubernetes. Now, since we defined the problem that Kubeflow is solving, let's take a look at Kubeflow. The Kubeflow project is dedicated to making deployments of machine learning workflows on Kubernetes simple, portable, and scalable. The goal is to provide a straightforward way to deploy best of breed open source systems for ML to diverse infrastructures. Anywhere you're running Kubernetes, you should be able to run Kubeflow. It enables developers to build custom ML workflows by easily stitching and connecting various components like building blocks. The capabilities provided by Kubeflow Pipeline can largely be put under three buckets: machine learning workflow orchestration, sharing reusability and easy composability, and rapid, reliable experimentation. So let's start with the first one, machine learning workflow orchestration. Let's look at a screenshot of a workflow that was run with Kubeflow pipelines. So for any workflow that you run with Kubeflow pipelines, you get this rich visual depiction of your topology of the workflows. So you can see that and understand what was run. Of course, this is just an illustrative machine learning workflow. When you build your own machine learning workflows, you can have all sort of different topologies. For a given step of the workflow, you can use your own tools and libraries of choice. A given step of workflow can be a single node instance that can run with different types of hardware, GPUs and TPUs, or it can also be something that runs in a distributed fashion. So long story short, this is just an illustrative workflow. And of course, you can build all sort of interesting topologies and applications and architecture. Now let's look at this specific example. In this particular example, it starts with data preprocessing and data validation step, followed by feature engineering step. And after that, we are forking out and training three different kinds of models in parallel. And each of these model training nodes encapsulate hyperparameter tuning within it. Then after that, we take the best models trained in each of these four and run them on the test dataset and analyze them, compare them, and then pick the best model. If that model happens to meet our performance threshold, we can deploy it to an online serving endpoint. So that is an example of type of workflows you can build and deploy with Kubeflow pipelines. For each step of the workflow, you actually have access to all relevant metadata and metrics at your fingertips. So as an example, let's take the training step. If it produces an auto C curve, you can visualize it right there. Or if it produces the rich metadata that can be visualized through TensorBoard is just one click away. So long story short, all the relevant information that you need is available right there at your fingertips. For each step of the workflow, you have access to configuration parameters that were passed in. And you can also see what were the inputs to that step and what were the outputs produced. So for any module trained with Kubeflow pipelines, You will not have to wonder, or you won't have the problem of not being able to answer how that model was produced. Because for any model trained with Kubeflow pipelines, you can go back to the corresponding execution run and you have all the relevant information at your fingertips. And this is particularly important for production machine learning workflows. So now let's take a peek under the hood and let's try to understand what exactly constitutes a Kubeflow pipeline. So Kubeflow pipeline consists of multiple steps, and each step of the Kubeflow pipeline is a containerized task. We are talking about production machine learning workflows and containers. They are the industry standard solution for portability, for repeatability, and encapsulation of dependencies. So we don't want to reinvent the wheel. That's why we build the solution that leverages containers at the heart of it. And of course, because this gets deployed on Kubernetes, we were going to choose containers. Now, as I mentioned previously, each step of the workflow can be very heterogeneous, can run on different types of hardwares. It can be a simple Python script or something that runs in a distributed fashion. It can be an Apache Spark job, or it could be a distributed model training job. Steps of the workflow can also call out to other Google services. So those are the steps of the workflow. Now, the other key aspect of the workflow is definition of the sequence or the topology of the workflow. The sequence in which the steps should run and how the data flows between these steps, how to connect the outputs of one step with the inputs of downstream steps. And then the third aspect of defining a pipeline is defining the set of input parameters that the end user has to provide. So the containerized steps or each steps packaged as container, the definition of workflow topology, and the specification of the input parameters together constitute a Kubeflow pipeline. So now let's see how you author a Kubeflow pipeline. When we spoke to target audience, data scientists, machine learning engineers, and machine learning practitioners, time and again, everyone said Python is their preferred lingua franca. So we said, okay, let's provide an SDK that is fairly intuitive and native to Python coders. So that's what we have provided. You get a fairly intuitive Python SDK that you use to specify the topology of your workflow. And specifying the topology, it's basically as simple as calling Python function that represent the various steps of your workflow and connecting them with inputs and outputs. Now, at this point, you may be wondering, but wait a minute. I said each step of the workflow is a containerized task. And here I'm talking about defining the workflow with a Python SDK and calling the steps Python functions. So there is some disconnect here. In its simplest form, because we are orchestrating containers, as long as containers follow a protocol on how they accept inputs and how they produce outputs, any containerized task can be converted into workflow step. And so that provides flexibility. In fact, we have a customer that has taken Fortran libraries that do numerical analysis, put them in a container, and call that particular container as a task in a Kubeflow workflow. So this provides a lot of flexibility, the ability to take a containerized task and convert it into a separate workflow. And the way you do that is you define a Python function wrapper for that container by invoking this SDK function called container op. You call the container op and you convert the Python wrapper function that you can now use while you're defining the workflow topology. But we realize that our target audience, data scientists and ML practitioners, they don't come in and build Docker containers on daily basis. They are not directly dealing with Docker on daily basis. In many cases, for the most part, the Dockerization becomes an implementation detail. So if you're writing a step of the workflow with Python, we provide simple utilities and function decorators to take your Python code and package it up automatically as a containerized task that you can call at the step of the workflow. So the key aspect here is while under the hood, each task is container, for the most part, ML practitioner and data scientists will deal with this Python code and we take care of the mechanics of Dockerization. We simplify the Dockerization for you. And of course, if you are running it on Google Cloud, you're going to call and leverage Google Cloud's amazing fully managed solutions for data analytics and machine learning, model training, and so forth. And for these services, we give you out-of-the-box connectors. So again, you don't have to focus on mechanics of calling out these services. We simplify that for you. You focus on your code and you use these out-of-the-box connectors. And of course, we will continue to improve upon this stuff. All right. So now let's look at the second key value proposition of Kubeflow pipelines, which is sharing reusability and composability. The key premise here is most machine learning applications today, they are built as a bespoke applications. But as a machine learning becomes more mainstream, its key purpose is getting embedded into multiple applications. You need a faster way to build machine learning applications. And the best way to do that is the ability to reuse the great work that others have done. You don't want to always start from scratch. If someone else has built an amazing workflow or an amazing component that can be used as a part of the workflow, you want to enable that. We want you to be able to find it easily, quickly, reuse it, and you're good to go. And of course, you will customize it for your own specific needs. So with Kubeflow pipelines, once you have defined the workflow, you can package it up as a zip file. And that zip file can be shared with others. They can run it on their own Kubeflow cluster. And because each task is containerized, you're not worried about the portability. Let's just say you develop the workflow on your development cluster and you have tested it. It looks good. And you want to hand it off to production team that will deploy it on a production cluster. And often what you want to do is, if you are working, say, in a large organization or you're a part of a broader community, you want to build an amazing application and share it with others so that they can leverage it and run it and build upon it. So if I were to find a Kubeflow application packaged as a zip file from someone else, I can load it up in my Kubeflow cluster. And I will get this UI form that is automatically created based on the inputs accepted by that pipeline. I will get that UI form, and without having to write too much code, I can actually fill in the parameters. I can try out Kubeflow application very easily. So that's a key aspect of being able to reuse and quickly try out work that someone else has done. And this reusability is not just for full end-to-end machine learning workflows or a complete pipeline. We have actually made it such that an individual step of a workflow can be packaged as a reusable component. So let's just say you're doing some very interesting feature engineering, or you have come up with very interesting way to do model analysis that you want everyone within your organization to follow. Well, that's great. Author that as a usable Kubeflow pipeline component, and they can use it easily within their own custom workflows. And because we are talking about reuse and sharing, I have to give a shout out to the AI Hub. It's a product we launched publicly this year. The AI Hub is your one-stop shop for sharing and discovery of relevant machine learning assets. It has multiple types of machine learning assets, from models to notebooks and so forth. And of course, a noteworthy category of assets in AI Hub will be Kubeflow Pipeline and Kubeflow Pipeline components. I want to give you an example of how easy it is to find a reusable component in AI Hub and use it as part of your own custom machine learning. It literally is a couple of lines of code. So you first start with this load component statement. You go to AI Hub, you find your Kubeflow pipeline usable component. There will be a copy URL. You hit a copy URL button, you get that URL. You then load, you then use it in this load component statement. You get the Python function representation of that step. And now you can use that step as part of your workflow when you're defining your workflow. So long story short, this whole aspect of reusing the great work that others have done, or if you have done great work, being able to share that with others is a key aspect of Kubeflow pipelines in conjunction with AI Hub aims to enable. And that's the key aspect of scaling out production machine learning. Now let's talk about third key value proposition of Kubeflow pipeline, which is experimentation. Machine learning is an applied science. You have to try many different ideas to find the ones that would actually work on your data for your application. Kubeflow provides an efficient way for experimentation. Long story short, we want to make it easy for you to rapidly iterate on your ideas, but do so in reliable and manageable way. So for any workflow or pipeline that is run on Kubeflow pipelines environments on a Kubeflow cluster, you get the full historical view of all the prior runs as well as your current runs. Not only that, you actually have filtering and search functionality to quickly find a past run. And once you find a past run that you're interested in, of course, you will have all the relevant metrics and metadata, config parameters, and so forth at your fingertips. And then you can hit the clone button and create a clone of that workflow and just run that clone if you just want to repeat a prior experimental run. You will get a UI form that shows all the input parameters, and you can tweak the input parameters and launch a slightly different variant of this workflow to try a different idea. So we have made it very easy to hit the clone button, tweak the variant with different configuration parameters, and run it. And in the future, we will actually extend that to enable rapid iteration with the code pertaining to a specific step of workflow as well. So right now, you can do rapid iteration with configuration parameter changes. And in future, we want to enable that for code changes as well. So at this point, you have done rapid iteration. You have launched many different variants of your workflow to see what works best for your data, for your use case. So let's just say you have 20, 30 or more different executions. Most of those are actually going to fail. Not every execution is going to result in the desired metrics. So now you have this long list of experiments, and in the list view of these experimental runs, you get to see most important metrics right there in the list view. So if you have got, say, 20, 30 different execution runs, you can quickly hone in on the ones that perform well or produce interesting results and ignore the ones that didn't perform well or didn't have interesting results. Select a subset of experiments that are interesting and then hit the compare runs button to get side-by-side comparison of these execution runs. And you can do a side-by-side comparison for a different config parameters and metrics. So you can quickly hone in on what was important about these executional runs. You can quickly hone in on the technique or the idea that led to interesting results. So that's how we enable rapid, reliable experimentation. It's reliable because the workflow itself is backed by containers, which can be run repeatedly. All your relevant config parameters and metrics are right there at your fingertips. Lastly, before we end, I would like to show what all managed and hosted services are available on Google Cloud Platform for relevant open source technology so that you can run your work either on premises or on Google Cloud Platform without any vendor lock-in. We have managed Jupyter notebooks on GCP, which leverage wide variety of TPUs and GPUs on Google Cloud Platform. You can also use AI platforms training and predictions, which supports multiple ML frameworks. And finally, you can run Kubeflow Pipeline as hosted pipelines on Google Cloud Platform. With that, I would like to wrap up this session. I would like to reiterate three things. Kubeflow Pipelines allows us to manage the scale and scope of ML projects. It can interop with your enterprise microservices. As Kubeflow open source community is growing and adding more features, it is becoming easier to use the Kubeflow pipelines. These are some of the links which you can look at after this session. And again, thank you for attending this session.